Now let us discuss 49. 4D, 5P, 5F, 6P orbitals are arranged in the order of decreasing energy. Okay, the correct option is, here they are asking that which orbitals having the high energy. We know that which orbitals having high n plus L values, that orbitals have high energy. Now let us try to calculate the n plus L values of given orbitals. The first one is 4D. It's n plus L value. Here we know that n means principal quantum number, L means azimuthal quantum number. For L you have the values here S, P, D, F 0, 1, 2, 3. For L you have the values of, for S it is L value equal 0, for P its value 1, for D 2, for F it will 3. Okay, now let us substitute the given values. Here principal quantum number means here coefficient, that means 4. Here orbital D means its L value is 2, that means 4 plus 2 is equal to 6. Now let us calculate 5p orbital. Its principal quantum number is 5 and its L value for P equal to 1, that gives rise to 6. Okay, now 5f. It's a principal quantum number, that means 5. Its azimuthal quantum number, that means L value F equal to 3. 5 plus 3 gives rise to 8. Now 6p. Its principal quantum number is 6 plus p, L value equal to 1. So it is value 7. Point which having the high n plus L values that have the high energy. 5f for having the high n plus L value. So 5f greater than, next 6p, its value is 7. Okay, here 4d and 5p having the same n plus L values. In this case, you have to see which have the high principal quantum number. That means which having the high n value, that's orbital having the high energy. Here 5p having its n value is high, then 5p is high energy than 4d orbital. So the correct order is 5f greater than 6p greater than 5p greater than 4. Now let us verify the given options. 5f greater than 6p greater than 5p greater than 4d. So our answer is 1 is our correct answer.